Hi, so I'm going to present a overview of a survey of context-aware image cropping. So the motivation for this is that there's different formats for capturing images, from 360 to 16:9 to 4:3, and as well as different resolutions, and there's different methods of displaying it, or different ratios and different resolutions. There's a lot of retargeting work done, retargeting from one format to the other, and the goal is to still retain information and retain or improve on the aesthetic quality that the original image has. So these are some of the crops using the same aspect ratio and same source image. Some obviously are good and some are bad. And so some of the applications are that photo editing to smart cropping for multimedia display and thumbnailing generation. So some of the connections to the other topics is that this idea heavily builds upon feature detection. Any advances in that field obviously has an impact on this field. So it starts off detecting lower level features, some color from contours to kind of contrast edges, and it goes from there to high level features such as people, faces, gaze, to be able to identify where the objects of interest are, so that when they crop, they aren't removing the items in their crop. And the other idea is aesthetic assessment. We'll build on this a little bit later, but this is actually a huge area in computer vision where you take an image and you're able to assess the visual quality. So this can go from more baked-in methods of photography rules to actually more complex modern methods, just as deep learning. So the major tasks for image cropping is first off feature extraction. Second, use these features to generate more high-level analysis of the whole image as a whole. And then there's generating candidates and aesthetic assessment. We'll focus on the second two because the first two kind of are more basic methods within computer vision. So for most of the methods, we'll talk about they use CNN for feature extraction, and they'll be able to construct importance maps, attention objects, and regions of interest, and as well as regions of discard. So an example is given in this image below, where you can see where it kind of looks at if it just looks at the region of interest, and where it looks at if it just looks at the region of discard. So it's able to look at kind of regions with features in high concentration. And we're going to focus on generating candidates. How do we actually kind of take these images and create crops that are meant to be aesthetically pleasing? And we're going to look at the aesthetic assessment that's being run on each of these crops to determine and output crops that are optimal. So for candidate generation, there's three main methods: attention-driven, aesthetic-driven, data-driven. So for attention-driven, we're really focusing on kind of the region of interest. That means generating saliency and attention maps for multi-scale features, from color intensity to orientation, and combine that into one single map. And this can also include ways such as like using the face detection, gaze detection, to be able to really accurately identify what are the prominent information in the image. So the advantage is that they can really crop what's important, the important features, identify those, and crop those appropriately for the given aspect ratio. But the limitation is that it doesn't really tune for visual quality or aesthetic quality. So it's a lot of times not going to look good. And aesthetically driven models, they improve on attention-driven models by having some of them use baked-in features to encompass good composition, and use SVM for discrimination of good and bad composition for the cropping that's available. For this one, it's fast. No need to train a huge data set, and you really can fine-tune it by kind of adjusting these rules. But it really can't crop more complicated compositions. You can only, it's built in kind of more of the basic rules. And to build on that, there's data-driven models, which one example was the grid angle-based image cropping, which uses CNN to generate the region of interest and discard, and to be able to use those to generate locations for the anchors, which is the 2 points on the rectangle that anchor the cropping, and to generate those points where the image is able to have the region of interest in a optimal position, and kind of discard the discarded region of discard as aesthetically pleasingly as possible. So CNN detects kind of more varied, complex composition as opposed to more baked-in ones in terms of generating these crops. But the limitation is you really need a good data set, which is actually something we're going to talk about having difficulties because kind of these are more human-driven annotations, and they need a lot of different annotations per source image, which is something I'll touch on a little bit once we get to assessments of aesthetics. So the other issue is just the huge number of boxes generated, and this goes from really bad methods, just a sliding window for the VFN, which to kind of sequential dissemination processes, such as choosing a high saliency crop, and then shifting it around until you get a good aesthetic score, and to more kind of reinforcement learning with the aesthetic reward function to improve on image crops and reduce the number of candidate windows. And one of the best methods currently reduces redundant local crops and crops that are too small or kind of aren't encompassing the regions of interest. This reduces the number of crops from millions to hundreds. And these are kind of the end results. And ours is grid-based method. So aesthetic assessment, it really needs a strong training model for the assessment. So it used to be just user studies, but they've built on that and expanded the number of annotated images, which used to be kind of randomly generated or selected from previous cropping methods, which isn't reliable and a good method of validating cropping, as it's built on the flaws of the previous cropping methods. And one such stronger database proposed in the Grid Anchor paper is using the survey to kind of generate multiple annotations per image. They were able to get kind of more than 200,000 crops for 3,000 images. And the other difficulty with assessment is actually being able to objectively measure the differences between the methods, and that used to be done with IOU and BDE. They often, however, are unreliable, as sometimes they actually give the uncropped a higher score than some of the cropped methods, even though that is the goal. So one such method proposed was Pearson correlation coefficient, Spearman's rank order correlation coefficient, which really kind of focuses on being able to rank the crops, the crops in order, not necessarily giving them a score, but kind of just being able to give them order and evaluate models that predict consistency with ground truths. So another thing that needs to be taken into account is the speed at which the assessment takes place, because this needs to be run over all the crops. So our early works used high-level features such as the rule of thirds, composition content. They were simple to set up, but they really needed better accuracy in terms of kind of assessing complex relations and compositions. So deep neural networks again were used in much of the recent methods. They need a lot of data, which we can leverage the previous data set mentioned, but they accomplish much better and much more close to human levels of aesthetic assessment. So future direction, there's still flaws in the current methods. They're still not quite at the level of manual manipulation, and they get confused when there's a lot of features on the images, and they aren't able to identify the key features, which is something I think can be added on by having more advanced feature detection and be able to discern between central and auxiliary features. And they aren't really able to take into complex relation between the objects in terms of composition. That's one of the things that also people taking into account when during manual manipulation. However, these methods so far hasn't been able to take that into account. So yeah, there's still some way to go to reach human level, but it's pretty close.